Welcome back. This is an Aleks training video on using a phase diagram to predict phase at a given temperature and pressure. Do you like these? I think these are easy. These are not so scary. You essentially need to know where at any point is going to be a solid, liquid, or gas. So if they're asking you the state and you happen to be in the middle of a liquid, tell them it's a liquid. If you find out that it's a gas, tell them it's a gas. It's that easy. All right, so remember before you start, everything needs to be in Kelvin. If they give it to you in any other thing, you have to convert it, and everything else should be pretty simple. Okay, so first question. Suppose a small sample of pure X is held at -36. Okay, let me find out what that is. 36 plus 273.15 is 237.15. So on this graph, I have to do 237.15. So I'm going to draw a line and then draw a box. Okay, so I've got a line there at 237.15 and a box there at 1.3, and I estimated it as well as I could. And so you're going to get where it crosses right here at this area, and they ask you a question: what will be the state of the sample? Right. So what will be the state of the sample? Would you say liquid? I would say this is a liquid. Okay. Next question. Suppose the temperature were held constant at -36, but the pressure is decreased by 0.8. What will happen to the sample? Well, I reduced it from 1.3 and I reduced it 0.8 atmospheres, so that left it at 0.5 atmospheres. So I left the temperature exactly where it was at 237.15, but I moved it down to 0.5 atmospheres. So it says, suppose the temperature is held constant, but the pressure is decreased. What happens to the sample? Okay, well, what would happen to the sample if you reduce the pressure? Okay, it's going to boil. So I would just say it will boil. So it's going to boil even though you didn't increase the temperature. That's pretty cool. Okay. Let's find out what's next. Suppose, on the other hand, the pressure is held constant at 1.3 atmospheres, but the temperature is decreased by 75 degrees Celsius. What will happen to the sample? So in this case, I left it at 1.3 atmospheres, but reduced the temperature down, and the temperature goes down to 162.15. Well, when I look at where that crosses, that's a liquid. Well, it started as a liquid, right? The first question was a liquid. So what would happen? Okay, so if it was a liquid to start and it's still a liquid, then nothing would happen. So pretty simple. I hope you can get this. I think you can. I think you can.